Hi class, this is Jeff. Today we're going to look at question 3.2, predicting ionic compounds formed by two elements. So the question is, decide whether each pair of elements in the table below will form an ionic compound. If they will, write the empirical formula of the compound formed in the space provided. Okay, so we get an understanding of what will make up an ionic compound. So let me bring in a periodic table. And so basically there's a line, zigzaggy line here, kind of goes through this area. And so everything on the left of that line are metals and non-metals are over here. So ionic compounds are really a metal plus a non-metal bonded together by an ionic bond. So that's all we have to decide. The covalent bonds are metal, non-metals, plus another non-metal. Okay, so if there are two over here, those would be the covalent bonds. But we're interested in ionic bonds, so that's where we're going to figure this out. And so, for example, if I have sodium and I have chlorine over here. Okay, sodium, it has 11 valence electrons. 2 of them are in this first energy level. It's not the valence shell. And then 8 of them are in the next one. And then there's 1 valence electron out in the third energy level. Okay, and so sodium and all these metals will give up electrons because it gets to an octet. If we take away that electron, then there's 8 electrons in that valence shell. So this becomes the valence shell of 8 instead of valence shell of 1. Okay, so group number 1 will, all those elements will lose an electron. Okay, and so they give it up to a non-metal. Okay, in forming the ionic bond. So if this lost 1 electron, this would be a plus charge because it was neutral. So we had 11 protons, 11 electrons, and then that is 0, but then we gave up that, so now we're 10, so this is a plus 1. Okay, so we gave up an electron. All right, so in group 2A, we have 2 electrons, and those get given up. And in group 3A over here, we have 3 electrons. Okay, and those get given up. Okay, so the groups 1A, 2A, and 3A, plus all these these metals in the middle here, are going to be positive cations. Okay, and then something like fluorine, it's in group 7A, so that means it has. So fluorine here has 7 valence electrons because it's in group 7A's. Oxygen has 6 because it's in group 6A, 5 for nitrogen, 4 for carbon. So if we go back to fluorine with 7 valence electrons, that means in this outermost shell, there are 7 valence electrons. And we're shooting for this rule, the octet rule, that says that electrons will be stable and will react to gain or lose electrons or share electrons. And so this one will gain that electron from sodium, and then that'll make 8. But so it had 9 valence electrons, or 9, total electrons, and 9 protons. So that was net 0. If we gained an extra electron, that would be 10 negatives. So that's be a -1. So we just have to take the valence electrons and add negative charges until we get to 8. So fluorine is 7 valence electrons because it's in group 7, plus 1 will make it 8. So it'll have a -1 charge. So -7 valence electrons plus another electron adds a negative charge. Oxygen will be, it has 6 valence electrons. So, we need 2 more to make 8. So, it'll be a -2 charge. And nitrogen is a -3 charge. And carbon can go either way, -4 or +4. Okay, so that's the rules of how to figure out the charges. So the metals are positive ions, and we can just make the group number the charge on it. Okay, and then the non-metals are negative charged, and then we take 8 minus the group number, and then that'll be the negative charge on those. Okay, so that aside, we can go back to our problems. So we have barium. And so if I look at barium, as a +2 because it's in group 2A. So it's going to be a barium is a +2. And then fluorine is in group 7A. And so 8 minus 7 is going to be a -1 charge. Okay. And then we just do crisscross. So we'll go there is one way to do it. So we get barium, and then fluorine is a 2. Another way is to look at barium. It has a +2 charge, so then we need -1 and a -1 to balance that out to 0. And so then that would be barium +2, and fluorine is -1, but we have to have 2 of them. So then that's what this shows us. So barium fluoride is going to be the name of this chemical, and it's going to be BAF2. Okay, rubidium is going to be in group 1. Where to go? Okay, so rubidium is going to be group 1, so it's this one. Okay, and so it's going to pair with sulfur, and sulfur is over here. It's going to be group 6A. So 8 minus 6A is -2. So we're going to have a -2 charge here and a +1 here for rubidium. Okay, so rubidium and sulfur. So rubidium is going to be rubidium is going to be +1, and sulfur is a -2. Do the crisscross, and so that's rubidium 2 sulfur. So that's be rubidium sulfide. And so that is ionic compound, and so yes. But sulfur chloride, that's not going to fit into the ionic compounds because sulfur is here and chlorine is here. So they're both non-metals. That's a covalent compound. So that one we don't need to do anything further because it's not an ionic compound. All right, so then the next one, so that was a no. And then rubidium fluorine. So rubidium was the +1, and then fluorine is the -1 because it was group 7. And then your 8 minus 7 is going to be the 1 -1 electron. So rubidium fluoride. And then so this is the formula, RBF. Okay, so this one was yes, 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 no. And so then we had barium fluoride and rubidium sulfide, and then sulfur was nothing. Sulfur chloride was not an ionic compound. And then a rubidium fluoride would be RBF. Okay, and that's kind of the theory behind how to solve these problems. So let us know if you have any questions. All right, thanks.